Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 12, Part 5, Multiple Linear Regression, Qualitative Independent Variables, and Interaction Terms. All right, if we would like to test whether or not the interaction term is significant, we can do this in two different ways. One way is through a t-test. So if we have y equals beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x1 x2, we could simply test HO. Does beta 3 equal 0? HA, does beta 3 not equal 0? And in this case, we could use our regression output and do a t-test. Right? The other way to consider this is by doing a partial f-test, where the full model is y equals beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x1 x2, and the reduced model is y equals beta 0 plus beta 1 x1 plus beta 2 x2. So for this particular case, right, k is equal to 3, right, and g is equal to 2, right? So the difference in the number of parameters is 1, and you can carry out a partial f-test. So make sure you go back to the earlier chapter 12 to look at how to test a single slope parameter or how to do a partial f-test with the full and reduced model. Let's do an example. All right, let y equal the response time in minutes, let x1 equal the dose of a drug, and let x2 be the drug type A, B, and C. Let's create indicator variables for drug type. Okay, so we could say x2, there's a few different options, is 0, 1, and 2. Drug A, drug B, drug C, right? In this case, our model would equal y equals beta 0 plus beta 1 dose plus beta 2 drug type. That's option 1. Option 2. Okay, this is option 1. Option 2. Let's let x2 equal 0 or 1. 1 for drug B, 0 else, and x3 be 0 or 1, 1 if it equals drug C, 0 else. So then our model becomes y equals beta 0 plus beta 1 times dose plus beta 2 drug B plus beta 3 drug C. All right. So essentially, if the indicator for drug B equals 0 and the indicator for drug C equals 0, well, then we are at having drug A. All right, so we're going to write a linear model with main effects only. All right, so I'm going to use option 2. Okay, so y equals beta 0 plus beta 1 dose plus beta 2 drug B plus beta 3 drug C plus epsilon. Okay. And we're going to fit the model, and we obtain the following. Y hat equals 3.35 plus 2.77 dose minus 1.30 drug B minus 3.05 drug C. All right, what's the mean difference in response between drug A and drug C while holding dose constant? Give your answer in numbers and in symbols. Okay, so let's do this generally first for drug A, drug B, drug C. Okay, so for drug A, right, the expected Y, and we could even say given drug A at a particular dose is equal to beta 0 plus beta 1 dose plus beta 2 times 0 plus beta 3 times 0. So all in all, we get beta 0 plus beta 1 dose. All right, let's do this for drug B. Drug B, the expected value for Y given drug B at a particular dose is equal to beta 0 plus beta 1 dose plus beta 2 times 1 plus beta 3 times 0. So all in all, we get beta 0 plus beta 2 plus beta 1 times dose. Let's do the same thing for drug C. Drug C, the expected value of Y given drug C at a particular dose. We get beta 0 plus beta 1 dose plus beta 2 times 0 plus beta 3 times 1. All in all, this equals beta 0 plus beta 3 plus beta 1 times dose. So if we want to know the mean difference in the response between drug A and drug C while holding dose constant, well, that's going to be the expected value of Y given drug A at a particular dose minus the expected value of Y given drug C at a particular dose, right? So overall, we get beta 0 plus beta 1 dose minus drug C, beta 0 plus beta 3 plus beta 1 dose. And if we do the subtraction, we get beta 0 plus beta 1 dose minus beta 0 minus beta 3 minus beta 1 dose, and all together we get negative beta 3, right? All right, if we were using the estimated mean difference, right, using our fitted line, well, what do we get? We get the estimated difference going to be negative beta 3 hat, which equals negative 3.05, which equals 3.05, right? So the estimated difference in response time between drug A and drug C is going to be 3.05 minutes. Fantastic, right? 3.05 minutes. Great. Move that over a little so it doesn't get too confusing. Okay. What is the mean difference in response between one test tube with 0.2 milligrams of drug A and one test tube of 0.8 milligrams of drug B? Write the answer in terms of the true betas and estimated beta hats. All right, so here it says, what is the expected value of Y given you have drug A and that the dose equals 0.2, minus the expected value of Y, given you have drug B and the dose equals 0.8. All right, so we're going to plug these in. We get beta 0 plus beta 1 times 0.2 minus beta 0 plus beta 2 plus beta 1 times 0.8. All in all, we get beta 0 plus 0.2 beta 1 minus beta 0 minus beta 2 minus 0.8 beta 1, right? So we're going to end up with negative beta 2 minus 0.6 beta 1, right? Okay, in terms of the estimated beta hats, right? So what is the estimated mean difference? I'm running out of room. Hopefully you wrote a little smaller than me. I'm going to make the stuff off to the right a bit smaller. I'm going to change the color so that I have room to write. All right, so this is my information off to the side. And ooh, that's a very bright color. Let me change it to red. Right, it's looking good. Okay, so this is in terms of the betas. This is the true difference between those two groups. If I want this in terms of the beta hats, then I'm going to say all right, so essentially, if you want to get the estimated difference, what you're going to do is you're going to plug in the estimates, okay? So you're going to get the estimated difference by taking negative beta hat 2 minus 0.6 beta hat 1. All right, negative beta hat 2 is going to be negative 1.30 minus 0.6 times beta hat 1, 2.77. And if you calculate that out, that's going to be 1.30 minus we calculate that out, that will give us an estimated difference between one test tube with 0.2 milligrams of drug A and one test tube of 0.8 milligrams of drug B is negative 0.362. So that is also in minutes. So we see that there is a so we see overall that the response time is faster for that 0.8 milligrams of drug B comparatively to the 0.2 milligrams of drug A. I hope you learned something today, and we're going to continue with this example in the next video.